For the second part of this section, we're going to talk about another type of asymptote called a horizontal asymptote, and also about graphing these functions. A horizontal asymptote is a horizontal line, and that's where the function is going on the right and the left ends. So as x goes to either negative infinity, which would be the left end of the graph, or positive infinity, which would be the right end, this tells us about what's happening with the y values. This is similar to the end behavior we talked about for polynomials. Only for this, instead of going up towards positive or negative infinity, we actually have our y values going towards a particular value. How we can find the horizontal asymptote is by comparing the degrees of the two polynomials on the top and the bottom of our function. So if we find the degree of the function on the top, if we call that n, and if we call the degree of the polynomial on the bottom degree d, then we can compare those two. If n is less than d, if the degree on the top is less than the degree on the bottom, then we automatically have y equals 0, which is the x-axis, as a horizontal asymptote for our graph. If the two degrees are the same, then we also have to go back and look at the leading coefficients for the two polynomials. We divide those, and that gives us our value for our horizontal asymptote. The third possibility is that the degree on the top is greater than the degree on the bottom. In that case, there is not a horizontal asymptote. And you'll see in some places that there may be an oblique, or this is sometimes called a slant asymptote. We're not going to worry about oblique asymptotes, so in this case, we can just say there's not a horizontal asymptote. Some important points about asymptotes. Vertical asymptotes only happen at x values that make the denominator 0, and it can only make the denominator 0. We saw that if it makes the numerator 0, then we have a hole there instead of a vertical asymptote. Horizontal asymptotes are either at y equals 0, which is the x-axis, and that's if the degree of the polynomial on top is smaller than the one on the bottom, or they might be at another value, and that's when the numerator and denominator have the same degree. Two things that are very different about the two types of asymptotes: the graph of a function can never cross a vertical asymptote, but it might cross a horizontal asymptote, because a horizontal asymptote only tells us about the end behavior on the right and the left ends. It doesn't tell us what's happening in the middle of the graph. In your notes, there are these steps to go through for graphing a rational function. I really recommend that you go through these steps on paper and not just try to get the graph off of your calculator, because there are some things that it's going to be very hard to determine just from your calculator, especially where the horizontal asymptote is. Let's look at some examples of finding horizontal asymptotes. Remember, for these, we're looking at the degree of the numerator and the degree of the denominator. In this one, our numerator is a constant. That means it has degree 0. Denominator has degree 1, since our highest power of x is x to the first. Now we're comparing these two degrees. The degree for the numerator is actually less than the degree of the denominator. That automatically means that our horizontal asymptote is the line y equals 0. This is the same as the x-axis. Let's see what this looks like on the graph. Notice for this one, because my denominator had two terms, when I put it in my calculator, I put parentheses around that so that I would get the right graph. This time we're just looking at what happens with the horizontal asymptotes. This affects what happens on the left end and the right end of the graph. And you can see on each end, the graph is looking more and more like a horizontal line. That's what it means to have a horizontal asymptote. And the line that it looks like it's getting close to is actually the x-axis. So the farther we go out this way, the closer it's going to get to the line y equals 0, and then the same thing on this end. Let's look at another example. This time the degree of our numerator is 2, because we've got an x squared here, and the degree of our denominator is also 2. If the two degrees are equal, then we have to do a little bit of work to find the horizontal asymptote. What we need is the leading coefficients of the two polynomials. So our leading coefficient for the top is 2. The leading coefficient for the bottom of this is 1. Our horizontal asymptote is going to be those two divided. And since this is talking about a horizontal line, to write the equation, we have to write it as y equals something. This is going to be y equals 2 divided by 1, or just y equals 2. We're going to graph this and see what it looks like. For this one, there were 2 terms in the numerator and 2 terms in the denominator, so I had to put parentheses around each one. Here's what my graph looks like. And remember, the horizontal asymptote is just talking about the end behavior, so it doesn't have any effect on what's happening in the middle of the graph. But if you look at the left and the right ends, on both ends, this is getting closer to what looks like a horizontal line. And we said our horizontal asymptote was y equals 2. So if we drew the line y equals 2 in there, that's what this is getting closer to on this end, and that's what this is getting closer to on this end. Let's look at one more example. For this one, the degree of the numerator is 2, and the degree in the denominator is only 1. This time the degree of the numerator is greater than the degree of the denominator. What that tells us is that there's no horizontal asymptote at all. And if you get a question that asks you about oblique asymptotes, this would have an oblique or a slant asymptote. But for this class, we're not going to worry about finding the equations for those. We can just say that there's no horizontal asymptote for this function. Let's graph this and see what it looks like. And I had to put the numerator in parentheses for this since it had 2 terms. This is what it looks like when there's not a horizontal asymptote. This looks more like the polynomials that we were graphing in the last unit. On the left end, our function values are just going down towards negative infinity. On the right end, they're going up towards positive infinity. It doesn't look like we're getting anything close to a horizontal line on either end. That's what happens when you don't have a horizontal asymptote.